Okay, guys, this is Objective 3.1c, Day 2. We're still solving quadratic inequalities on one variable, and your objective is still to solve, and then choose the sign chart method that helps determine the solution set. So that has not changed. However, I would like you to put this in your notes, in the little section above the words guided practice, in that little space. Okay? And you don't have to write it word for word, just get the basic gist of this information. After putting the inequality in standard form, if A is negative, it's going to throw everything off. Everything we learned yesterday, it's going to reverse everything. It'll change the positive intervals to negative intervals and the negative intervals to positive intervals. So to avoid that, we are going to divide all the terms by the -1, and we're going to switch the inequality. So if it says less than, we're going to switch it to greater than, vice versa. Also, sometimes, infrequently, but sometimes, the 0 is the only solution. Sometimes. So what we're going to do today in your notes is we are going to do an example where the A is negative so that we can illustrate that first statement. And then we'll do one where the only solution is the 0 so we can illustrate that situation. Okay? Do you need a little bit more time? Speak up. Okay, I'll press pause. First problem that I'd like you to do, we're going to change the problem that's actually in your note page just a little bit because I printed out the wrong problem. I changed it. So I'd like to change number 1 to say this. Okay, cooperate, pen. Hello. There we go. Negative. And then just tuck a quantity around, 6x squared minus 6, close your quantity, greater than -5x. So let's make that little adjustment. Okay? And then we're going to go through the same process we went through yesterday. We're going to put it in standard form, figure out what kind of intervals we're looking for, all that jazz. Here we go. -6x squared plus 6 is greater than -5x. And then, of course, we need to add 5x to the center so that it goes in its proper place. And we get -6x squared plus 5x plus 6 is greater than 0. So this is something new for us today, right? Our A term is negative, and we can't really divide out the 6 because that'll create fractions. We don't need that jazz. But let's divide out the negative. Because if we don't, remember when I was showing you yesterday how the parabola opened up and then if the answers were negative, it'd be between the zeros, and the answers outside would be the positives and above the zeros? Well, when your A is negative, do you know what happens to your parabola? It flips upside down. So now the positive stuff is between the zeros and the negative intervals are the outer or the union. So to avoid that situation and learning how to handle that, we can avoid it. We'll just avoid it by dividing out the -1. As long as we divide everything by -1, we don't change anything, correct? So if we divide this side by -1, and we divide this side by -1, as long as we remember to reverse our inequality, we're in good shape. So that would be 6x squared minus 5x minus 6 is less than 0. And now it feels better. It's flipped my parabola back right side up, and it's going to give me what I want. It's still going to give me the answers I'm looking for. So let's determine what kind of numbers we want now. Turn your brain on. Numbers that are less than 0, well, will be. So we're going to be looking for the negative intervals because they are less than 0. Okay? And then, of course, we need to factor. But this time, our A is not 1. Dang it. So that adds an extra step. So don't get all in a hurry thinking you've got this. Unless you've got this. So let's take our quadratic and set it equal to 0 so that we can find our zeros. Excuse me. And let's factor. At this point, if you would prefer to use your quadratic formula, I'm not going to dictate to you that you can't do that. But I'd prefer to factor. So we get 6 times negative 6 is negative 36 using our AC method. And our B term is negative 5. So we're looking for two numbers that multiply to negative 36. So I know I need one negative and one positive for sure. That add to negative 5. So negative 9 and 4 will give us those. Now yesterday we could just take our A term and split it, x and x, but our A is 6. Do you know how you're going to split it with a 2 and a 3 or a 6 and a 1? You don't, right? So what we have to do is break our center term up. So 6x squared minus 9x plus 4x, which equals negative 5x, minus 6 equals 0. Excuse me. And do you guys need me to come up here, people in the back? Yes? Okay. So we're going to take 6x squared minus 9x plus 4x minus 6 and cut it into two groups, front and back. Factor the front and the back like we know how to do. What's our common factor up front? Try again. Thank you. Times 2x minus 3. In the back, what's our common factor? Positive or negative? So plus 2 times, there we go, equals 0. So our common binomial factor is 2x minus 3, and our other binomial factor will be our leftover numbers. Okay, so you can see there's a bit more work involved. The better you get at factoring, the faster, of course, this will go. Now we need to find our zeros. So 2x minus 3 equals 0, and 3x plus 2 equals 0. I'll go ahead and solve mine. You solve yours. You don't need me to solve that little baby linear. You've got that. Okay, so I have the zeros, 3/2 and negative 2/3. Okay, so now we know our zeros, which means we can take our number line and break it up into intervals. So, I'm just going to scoot this problem over a bit so that I can continue to work on this screen. Okay, so continuing our work. I'll go ahead with method 2 first, just for fun. Okay? So remember with method 2, when we're doing our sign chart, we stack our two binomial pairs, 2x minus 3 and 3x plus 2. And we create our number line. And we plot our zeros, which are negative 2/3 and 3/2. And we determine if we want them or not. Were they part of our solution, the zeros? Or did we just want the positive or negative? I don't even remember what we wanted. What did we want? So we don't want our zeros, so I'm going to go ahead and put parentheses on them so that we can deny them as part of our answer. And then we're going to find our zeros. So what's our 0 for 2x minus 3? It's right here, yeah? 2x minus 3 is 3/2. You guys solved it. It's right there. Okay, so that's the 0 for your top term, which means negative 2/3 is your 0 for the other one, right? And to the left of this 0, to the left of 0 is always negative, correct? So this would be negative and this would be negative, and to the right of that 0 would be positive. Same thing goes for the bottom one. To the left of 0, we will get negative answers. To the right of 0, we will get positive. And then we just multiply our two signs. So negative times negative creates a positive interval. Do I want that? No, I don't want that. Okay, so no to that one. All right, negative times positive is negative. Yep, I want that. And then positive times positive is positive. I don't want that. So that's no good. So my solution is I want the negative interval between negative 2/3 and 3/2. That's what I want. Okay? So that's one way to find the set of numbers that will make our inequality true. All right. Continuing on with method 2, I'm going to continue to move things out of the way. What? What? Oh, sorry, Jonah. How did you get that? Okay, so let me explain to you why that doesn't work. I'm going to put this on pause. Okay, our other option is to take a number line and plot our zeros again. And we decided we don't want them because they are not part of our solution. Okay, and then what we're going to do is we're going to pick numbers from each section to test in our equation. So shall we pick 0? Oh, that's not 0. Shall we pick negative 1? And shall we pick 0? And how about 2? Yeah, because that's 1.5, so we should probably pick 2. So we're going to pick those x's, and we're going to find out what happens. So we have 6x squared minus 5x plus 6 is our original, correct? Our inequality. All right, so let's plug in a negative 1. So 6 times negative 1 squared minus 5 times negative 1 plus 6. I believe the answer to that is 5, which is positive, right? And we don't want that. If you check me, that's 6 times 1, 6. Oh, wait. It would not be 5. What did I do wrong? Did I do something wrong? It's 17 because they're all positive. So never mind. I must have been thinking of the other problem I did today. Okay, we plug in 0. Hang on a second. We have a problem. Isn't this a minus 6? Check it out. Yeah, so guess what? I was right. I just wrote the wrong problem down. It was a minus 6. So it's minus 6. So that is 5. All right. So if I plug in a 0, what do I always get when I plug in 0 in a quadratic? The c term, which is negative 6. I don't even want to do the math. I can. 6 times 0 squared minus 5 times 0 minus 6. It's negative 6. That's negative. I like that. So, yep, I want that. You see the pattern that's developed over the homework that we've done, right? So let's do 6 times 2 squared minus 5 times 2 minus 6. So that's 6 times 4, 24. Minus 10 is 14. Minus 6 is positive 8. That's positive. We don't want that. We don't want that section where the negative 1 exists. We don't want that section. So our solution is still the same. Negative 2/3 to 3/2, non-inclusive. Okay, so the next problem we have here, number 2, 3x times 3x minus 8 minus 5 less than or equal to negative 21. Let's multiply. So that's 9x squared minus 24 minus 5 less than or equal to negative 21. In our quest to put it in standard form, yeah, it is. Thank you for that. Minus 24x. Thank you. We're going to add 21 to move it over here so that we can get our 0. 9x squared minus 24x plus 16 is less than or equal to 0. So now we're going to make our choice. What numbers are we looking for? What types of numbers? Less than or equal to 0. Negative and 0. So those are the types of numbers we're looking for to satisfy this inequality. We want negative numbers and we want zeros. Okay, so let's factor this guy out. That's 9x squared minus 24x plus 16. I'm seeing a perfect square trinomial. Those factor really quickly when you learn. If I break this up to 3 and 3, 3x and 3x, and I break this up to 4 and 4, 3 times 4 is 12, and 3 times 4 is 12. 12 plus 12 is 24. How do I make those positive 12s negative 12s? They would both have to be negative, don't you think? So I'm going to have to make these both negatives. Okay? So this would be 3x minus 4 times 3x minus 4. When you train yourself to see them, you don't have to do the AC method and break it up and try to factor it. You just train yourself to always look. When this occurs, it's always the first question I ask if they're perfect squares and they're both positive. I'm on alert that I should try this first because it saves time. Let's set them equal to 0. Do I have to set them both equal to 0? Absolutely not. We only have 1 0 this time. So that's 3x equals 4. So x equals 4/3. And there's my 0. Okay. So I'll go with method 1 this time first. So we're going to take our number line and we're going to chart our 0. Now, are we including our 0 this time? Yeah, because remember that we were looking for 0. So we'll put some brackets to indicate that we want to include that in our answer. And we're going to pick numbers, well, we're going to pick numbers on each side. So what number would you like to choose on the left? Come on, do 0. Yeah, 0. Let's choose 0. What number would you like to pick on the right? 2. All right, so we'll pick 0 and 2. We'll put them in our little chart here. So that's our x that we're going to plug in. So we're going to plug it into 9x squared minus 24x plus 16. And when we plug in zeros, we always get out the constant. Right? And so that's positive. So that's positive. And this time, do we want that? We want negative, so we don't want that. No to that. I don't want that section. It's no good. Okay, let's plug in a 2. So 9 times 2 squared. Well, that's 9 times 4. 9 times 4. Negative 30, that's 36. And 24 times 2 is, that's negative 48. 36 minus 48, negative 12. Negative 12 plus 16 is 4, which is also positive. So this is positive, and we don't want that. We want negative. But listen, folks, I didn't get any negatives. So there's no negative answers. But there is a 0, yes? So remember what I said at the beginning. Sometimes 0 is the only solution. So this time our solution is, in interval notation, the interval of 4/3, and only 4/3. If I were to pick any other number in the whole universe to plug in for x into my original equation inequality, nothing would work except for 4/3. That's the only thing. Question? All right, so for method 2, where we stack our binomials. We would stack 3x minus 4 and 3x minus 4. We need to stack them both. And we would create our number line and plot our 0. And we know that this time it's the 0 for both of them, correct? So to the left of 0, well, we'll just plug in a 0 so you can trust me. 3 times 0 is 0, right? 0 minus 4 is negative. So it's going to be negative in both those positions. If I plug in a 2, which would be over here, yeah? 3 times 2 is 6. 6 minus 4 is positive 2. And you can see it again. Negative times negative is positive, just like happened up here. Positive times positive is positive, just like happened here. But, so we don't want that. Nope. And nope. But what we do want is our 0. So we want that guy. So that's how you would use the sign chart to help you find that. So I'm going to stop the video.